Hello guys, how's it going? We are starting our next lesson, which is about sequences. We're going to split this into two different lessons. We're going to do arithmetic sequences today, and then we'll do geometric sequences in our next video. Um, you are going to need a foldable for today. This is what it looks like. So it has like these numbers on top, and then it says arithmetic sequences on bottom, and on the back are all these examples. There's 3 examples and all sorts of fun stuff. So you're going to want to rip this out. How you fold this is you're going to kind of fold it into thirds. So let me just show you really quickly on how I folded this. So I have arithmetic sequences, just the title, and then I just folded the example 1, example 2, and example 3 upward, like so. So this is what it looks like in my notebook. If you need to pause the video to make this, please do. You need to pause the video to get the title of the notes for today, which is right here, right? Arithmetic sequences and the date. Please do so. But this is what it looks like when it's all folded up, like so. So then you can lift up the title, and then you have examples 1, 2, and 3 here. So we're going to switch over, and we are going to look at this foldable. Here it is. 1, 2, and 3, and we want to actually scroll down because we're not going to write on that page. And we're going to talk about what is an arithmetic sequence. So sequences are just patterns. Okay, like 2, 4, 6, 8 is a pattern. Who do we appreciate? I can't not say that every time I say that. Anyway, 5, 10, 15, 20 is a sequence. It's just any sort of pattern. Specifically, when we're talking about an arithmetic sequence, it's a sequence, obviously, right? It's in the name. And let's put in parentheses maybe pattern, where the difference between terms, so what is going up every time or if it's going down every time, but the difference between terms is constant. And so what that really means is that we add or subtract the same number every time. The same number every time. So for example, like 5, 10, 15, 20, I'm adding 5 every single time. So that's an arithmetic sequence because I'm adding 5. If I did like 0, -2, -4, -8, that would be an arithmetic sequence because I'm subtracting 2 every single time. So here in this example, to go from 3 to 7, I'm adding 4. And then 7 to 11, adding 4. And then 11 to 15, adding 4, right? And I can keep going, 15 to 19, adding 4. So because I'm adding 4 every single time, this is an arithmetic sequence. Now, there's 2 types of equations that we can write when we're looking at arithmetic sequences. The first one is called the recursive sequence, recursive formula. And this is used when we want to find just the next term in the sequence. So if I know the 50th term, then I can use this equation to find the 51st term. But I would have to know the 50th term already, right? So this is like if I want to know the 10th term, I have to know the 9th term. But in order to know the 9th term, I have to know the 8th. So you have to know all the ones before it. So this isn't always super, super helpful, but sometimes it is. So the recursive formula So we use a sub n instead of x, okay? And then an instead of y. And so we'll look at these. It'll look very similar to y equals mx plus b, but we're just using different letters. So this a just tells me that it's a sequence. So we use a sub n plus 1. Notice that this is down below. It is not this. That is not what I'm looking at, okay? I'm just going to erase that. It is written down below as a subscript, okay? So this says the next term in the sequence. N is your term, right? So the next term in the sequence, the next number, right? So if I know 19, the next number would be 19, the current term. So a sub n is the current term. And then what am I doing every single time? In this case, I'm adding 4, but we say plus d, the difference. Now, I'm going to go through this very, very carefully. A sub n plus 1 means the next term. Okay, so the next number in my sequence. This is an A, sorry, it looks kind of weird. A sub n is the current term. I'm going to kind of take up some space here, but that's okay. D is the common difference. What am I doing every time? Am I adding 4 every time? Am I subtracting 6 every time? What am I doing? Okay. Now, so all this tells you, so like I'm going to write the recursive equation here as an example. I would say a sub n plus 1. So the next term in the sequence is means equals, the current term, and in this case, it's plus 4. That's literally all it tells me, is that, like, I have no idea what those numbers are, right? I could go 0, 4, 8, 12, 16. Am I adding 4 every single time when I do that? Yes. But is that the same sequence as this? No. So, I could start at 2, and it would be 2, 6, 10, 14. I'm adding 4 every single time, but that is not the same sequence as this. So all this means is, hey, you just add 4 every time. So I also have to include a really crucial piece of information, which is, where am I starting? So a sub 1 here means the first term. Where am I starting at? Right? So I need to know a starting point, because if I start at 0 and add 4 every time, I get a different sequence than this. So in this case, the first term in my sequence is the first number in my sequence, which is 3. So that is the recursive formula for this sequence. So all this tells me is, hey, the first term is 3. And then the second term will be 3 plus 4, which is 7. And then the next term will be 7 plus 4, which is 11. And then the next term will be 11 plus 4. So it's just telling me I'm adding 4 every time, but I'm starting at 3. The explicit formula, this is used to find any term. So if I want to know in this sequence, what is the 60th number, right? If I count out 60 numbers, what is that? I don't want to do that using this equation, because I'm going to have to find every single number up until 60. I don't want to do that. That's a lot of work. So then we use what we call the explicit formula. And so the explicit formula is, hey, the term in the sequence, the current term, so the 60th term, right, is equal to the common difference times n, which is my term number, plus b. So this is pretty much y equals mx plus b right here. We already know that a sub n is the current term. We know that d is the common difference. B Here is the 0th term. So that's kind of like this imaginary term out here. And then n is the term number. So if I were to write the explicit formula for this equation or for this sequence, it would be, hey, whatever term I want to find is equal to the common difference, d, which is 4, right? I'm adding 4 every time. N, I don't know what n is, plus b. Remember, so b is like this imaginary number here. So what number would go there? Well, I'm adding 4 every time. So to go this way, I'd have to subtract 4. So it would be -1. And what that allows me to do is, hey, if I want to know the 60th term, I'm going to plug in 60 right here. And whatever I get, that's the 60th number in the sequence. If I want to know the 100th term, I'm going to plug in 100. And it's going to tell me what the 100th term is. Okay. So we're going to look at 3 examples of doing this, and hopefully it'll make sense. So let's look at example 1. And of course, I can only fit like A and B at once, so that's okay. So example 1, find the next 3 terms in the sequence. So I look here, what do I do to go from 5 to 12? And I add 7, 12 to 19, add 7, right? Same thing for 19 to 26. So the next 3 terms, 26 plus 7 is 33. 33 plus 7 is 40, and 40 plus 7 is 47. The ... just means that this sequence goes on forever, right? You just keep adding 7 forever and ever and ever. So then it says, write the recursive formula. Okay, so looking up above at my notes, I see that the recursive formula is the next term in the sequence. That's my a sub n plus 1. Make sure you write that below. If you struggle with good handwriting, this is your time to practice because this n plus 1 has to be below the a. So it's a subscript. It's on the same line. It's just written slightly below. So the next term in the sequence is equal to the current term. Again, this n has to be a subscript. And then plus whatever I'm doing every time. So in this case, I'm adding 7. So plus 7. And that, okay, but 0, 7, 14, 21, 28, right? That's a sequence that adds 7 every time, but that's not the same as this. So I have to include that first term, that starting point, which in this case, the first term is 5. And that's it. That's my recursive formula. Okay. Holy moly. Okay. Oh, I didn't erase it. Okay. It's not letting me just clear the whole page. Okay, so then for C and D, it says write the explicit formula. Well, again, if I look up above, the explicit formula says, hey, the term is equal to my common difference, my D, which in this case is 7 because I'm adding 7 every time, N. And then I want the 0th term. So I'm going to scroll up real quick. The 0th term, this guy right here, right? So if I subtract 7, my 0th term is going to be -2. And that's my explicit formula. Once my explicit formula is found, I can do part D that says find the 39th term. So I'm going to plug in 39. So I have A sub 39 equals 7 times 39. That is not a subscript. This is not a subscript. This one is minus 2. So 7 times 39 is 273 minus 2. So I get 271. So A sub 39 is 271. So in this sequence, in this pattern of adding 7, adding 7, adding 7, right? If I do that 39 times, the 39th number in the sequence will be 271. So that's the benefit of using the equation versus you want to just add 739 times, because I definitely don't, right? So I want you guys to pause the video here and to try example 2 on your own, and then we'll go through it together. But I want you to pause the video and try it. Even if you get it wrong, at least you tried it, and then we'll go over it here in a second. Okay, so hopefully at this point you guys gave it a try. Again, even if you messed it up, at least you tried. So let's look here. To go from 6 to 16, you add 10, right? 16 to 26, add 10. So that's going to be my common difference, is adding 10 every time. So find the next 3 terms. 36 plus 10 is 46, plus 10 is 56, plus 10 is 66, and then this just continues on. Then it says write the recursive formula. Okay, so the recursive formula just says that the next term in the sequence, so a sub n plus 1, is equal to the current term, so whatever I currently have, and then what am I doing to get to the next term? I'm adding 10, so plus 10. So really, this is the only part that changes in the recursive equation. And then you're like, okay, but 10, 20, 30, 40 is adding 10 every time, and that's not the same as this. So you have to tell whoever's looking at the equation where to start. And in this case, the first term is 6. So hopefully that makes sense, right? This is just saying, hey, all I'm doing is adding 10 every time, start at 6. Okay? Now let's look at the explicit formula. So the explicit formula says, hey, whatever term in the sequence I'm looking at, a sub n, is equal to my common difference, which is 10 times n, and then your 0th term. So again, scroll up, let's look. That is this number out here, right? The 0th term. So if I subtract 10, I get negative 4. So that's going to be my 0th term. And once I have that, notice this is just y equals mx plus b, right? This is my slope. What am I adding every time? This is my y-intercept. What is my starting value? My 0th term. So it's just y equals mx plus b. Just instead of y, it's a sub n, and instead of x, it's n. That's literally the only difference. So then once I have this equation, it says find the 100th term. No problem. So I say, hey, term 100 is equal to 10 times 100 minus 4. Well, 10 times 100 is 1,000 minus 4 is 996. So the 100th term in this sequence, in this pattern, is 996. So I can either write out 100 numbers until I find that, or I can just write the explicit formula and solve it. Okay, one more. And again, on this one, you guys, example 3, I want you guys to try this one on your own. So I want you to pause the video, try A, B, C, and D on your own, and then when you're ready to go over it, hit play and let's do it. Okay, so hopefully you guys gave it a shot. Even if you mess up, that's okay. You can fix it. At least you tried. Let's look here. To go from 9 to 5, I subtract 4. And then 5 to 1, I subtract 4. And it looks like all of these, I'm just subtracting 4. So since I'm subtracting the same number every single time, it's an arithmetic sequence. Then it says find the next 3 terms. So negative 7 minus 4 is negative 11. If I minus 4 again, I get negative 15. And if I minus 4 again, I get negative 19. Okay. Then it says write a recursive formula. So that tells me that the next term in the sequence, the next number, is whatever the current number is, and then what am I doing every time? I'm subtracting 4. And then I have to know where to start because there's a lot of sequences that subtract 4, right? So my first term is 9. And that's it. That's my recursive formula. If I look at my explicit formula, this is the one that's kind of in the form of y equals mx plus b. So a sub n, right, that's my y, equals my slope. What am I doing every single time? I'm subtracting 4. And then my b is my 0th term, so the number that would be before 9. If I'm minusing 4 to go down, then I would add 4 to go up. So 9 plus 4 is 13. So this is going to be 13. And then if I want to find the 25th term, all I'm going to do is plug in 25 anytime I see an n. Okay, so negative 4 times 25 is negative 100 plus 13, which is negative, 13, which is negative 87. So the 25th number, if I count out 25 numbers of subtracting 4, subtracting 4, subtracting 4, right? The 25th number would be negative 87. Oh, I did not mean to do that. Sorry. So we have some practice of this, guys. Hopefully it's not terrible for us right now. It's just basically y equals mx plus b, and then that recursive equation is like the same thing over and over and over, just changing a couple numbers. So if you have any questions or if anything in these notes don't make sense or you need help, just make sure you reach out, and we'll see you soon.